session. So the recordings will be available on Huner's YouTube channel, and also it's streamed live. So your friends also can look at those who are interested but did not join. And this will be useful for them to join in the next batch. So just to recap what we have done in the introduction. So there are three types of employability skills you have to improve. The first being problem solving, the second one personal attributes, and third technical knowledge. So technical knowledge comes from your college. You have taken many technical subjects, courses to graduate, and we are not going to touch. So what we are interested here at Huner is to mentor the problem solving and personal attributes. So as we discussed in the last session, the three employability attributes. Technical knowledge is for your eligibility criteria for writing a test. And the second one, problem solving, once you have solved the eligibility criteria, then second one is again selection criteria for the interview. So you have to go through the problem solving skills test, and once you are successful, so you will be called for interview. Then in the interview, the companies are going to look for the personal qualities, the self-confidence, flexibility, willingness to learn, emotional intelligence, punctuality, efficiency, and effectiveness. That is nothing but reflectiveness. So just getting marks is not enough. You get marks, you study for the technical aspects, and you are eligible for writing any test. And later, and once you are filtered, then the problem solving skills and the personal qualities are going to come into picture. These skills are not just important to get a job or a career, also to retain your career. So you have to keep improving the problem solving skills and the personal attributes. Once you start gaining the experience, you might become engineer trainee, then engineer, then assistant engineer, maybe executive engineer, manager, general manager, or a CEO of the company. So all the time you need to improve your problem solving skills and personal qualities. So we just discussed in the last session the problems and the issues with the rural engineering college, for which Huner is willing, or Huner is trying to address these issues. This problem solving skills as well as personal attributes. So this is what we discussed in the last session. The students who might have missed the first class, and this is just a recapture. Now I'm going to start today a brief history of engineering. Some of you might have known the history, but this is just a recapture of what was happening in the past and what is happening in the current and what is going to happen, what are the future jobs, the future options for engineers. A small discussion and a brief presentation. So we are calling it as engineering history today. So let me share. Okay, are you able to listen to my voice clearly?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, said someone, I think, are unable to hear. Is my voice clear? Can you please say thumbs down if you are unable to hear? Say thumbs down. Only those who could not hear, please say thumbs down. Okay, looks like I think all of you. Okay, now I'm going to ask you a few questions before we start to ignite your brains. So what are the tallest engineering structures in the history so far? Hello? Anybody can say. What are the?
Burj
Yes?
Khalifa. Burj Khalifa.
Khalifa. Okay, next.
Eiffel Tower.
Eiffel Tower. Yes, very good. Next.
CN Tower.
CN Tower. Okay, nice. What else?
Pyramids.
Pyramids. Who said this?
Shanghai Tower.
Shanghai Tower. Okay. Which is
An electrical
old-
signal tower.
electrical signal
Wi-Fi
tower.
signal tower. I
Okay.
doesn't know that name, sir. But
Okay.
Wi-Fi signal tower is the largest engineering construction.
So we're talking about the tallest structures. I think one of you said the pyramid, right? What do you think?
sir.
How old is the pyramid? How old? Let me ask. Okay, how old is the pyramid built?
4,500 years old.
4,500 years. Okay, anybody guess? But the meantime, co-host, is it live? Can you please tell me? It's recording or live? Co-host. So we have a co-host. Let's thank Ishan. So he volunteered and he's one of our team who supports Huner activities, social purpose. May God bless him. Is it live, Ishan? And it's recorded.
One
Okay.
second, sir. I'm going to check 1 second.
Okay, great. So if it is not live, please let me know. So the question here, the tallest structure, I think most of you are aware. And someone said the Burj Khalifa, of course. I see every day the Burj Khalifa here from my window. And
Sir, China bridge, sir.
okay,
Indian.
okay. So there are many tallest structures, but the oldest engineering structure so far is pyramid. Okay, and there are a couple of pyramids. It's not just one. If you go through, can you please mute? Can you please mute? Co-host, can you? Okay, thank you. Okay. So there are many pyramids. If you go on Google, the tallest pyramid is called Gaza Pyramid. And it was built almost 5,000 years ago. And so far, we don't know how it was built. There are many theories, many hypotheses that it was made by the jinn, it was made by aliens, it was made by the huge elephant. So there are many hypotheses and a lot of theories. But So far, we don't know exactly how they were built, but they have built. You know, the difference between the Gaza pyramid, say close to 160 meters. The height is close to 160 meters. And the next tallest structure was Eiffel Tower. The next tallest structure was Eiffel Tower. Okay. You know the time difference between now the Eiffel Tower and the Gaza pyramid is almost like 4,600 years. 4,600 years. But whereas if you see the Eiffel Tower and the Burj Khalifa is almost like 120 years. So it took almost 4,600 years from pyramid to the Eiffel Tower. But whereas we could build from Eiffel Tower to Burj Khalifa in a span of 120 years. So what would have happened? Why we were unable to build any tallest structure after the pyramid? Any guesses? Hello?
Actually, no data is provided from that in that year, sir.
So
There may
there was no data. Okay.
There may be not the strongest engineering structures, so they are degraded over time.
Okay. Any other? It should have been possible, right? So when we were able to build Eiffel Tower and Burj Khalifa in a span of 100 years, so there are generations not disappeared suddenly. But if you see the difference, 4,600 years, it's a huge. It means that no one thought to build the tallest structure after pyramid. Something fishy, right?
Yes, sir. Maybe the people were busy in the wars.
Oh, 4,600 years wars.
Yes.
Someone raised the hand. 4,600 years war. Okay, what else? Do you agree or do you believe that the people who were responsible to design and build the pyramid were also like engineers, but they are not certified from like your college or my college? They were engineers without certificates, right? Because they built so much, so strong, and they used the trigonometry and the structural integrity so high that still it is standing, right? There was some engineering marvel there. There was, right, engineering marvel. So what would have happened? So this is called the history of engineering between the pyramids until the Eiffel Tower. So there are many things happened. And there is one story why there was no structure built after the pyramid. How many of you know the Moses in Bible? Hello?
Yes, sir, I know, sir.
Hello? Yeah. So Moses was in
Sir,
pyramid,
Moses,
right?
sir.
Yeah, he was basically building the pyramids, right? Then he took the revolution politically. Then he took all his engineers, teams, and he left Egypt and went to other places, right? Yes.
Yes, sir.
So the pyramids. So what was the objective of building a pyramid? Hello. What do you think? What was the object to build? Is there any use? Is there any use of pyramid?
To store the dead bodies of their ancestors.
Ah,
Mummies.
mummy. Is there any use for the public? Hello. Is there any use? Hello.
Egyptians are trusting that their ancestors will be coming again when
But
they store in
any
pyramids.
use for the public?
Yes, sir. That represents the changes in nature, sir.
Mhm. Okay.
Tourism developments.
Sir, there are many symbols how they built and how the ancients was participating in their activities, and so many things they mentioned in pyramids, sir. May that is a one of use by
Mhm.
construction of pyramid.
Okay. Whatever it may be. So what happened? There was a revolution, and the engineers left Egypt, and they don't want to build the pyramids because the pyramids were built for the king, right? The pyramids were built by the king, not by the public, not by the engineers. So I can say that one of the greatest engineers so far we know in the history was, say, the prophet Moses, as per the Bible and also some other ancient texts. And they flew from pyramid Egypt and went to somewhere else, not to build pyramid, but to build the civilizations. So what kind of civilizations they built? So that's what we talk about, the Roman and Greek engineering. So they had acquired the construction knowledge for the pyramids, and they acquired some engineering knowledge, and they started building societies. They started building cities, started building agriculture, irrigation, because there was no king on them to say, just build the pyramid. No. So they had those skills and experience and knowledge. So 5,000 years ago, they just left Egypt and went to somewhere else and start building. And again, many theories says they went to Greek, Roman, it means Europe basically. And they started building civilizations. And the public started getting fruits of the engineering. So that was the starting point of engineering. As far as a book called The Betterment of Human Condition, the author was Dr. John G. Jones, one of the Canadian, and he was one of my professor in Canada. So he wrote a book, and you can go and do Google about engineering history on the betterment of human condition. So that's how the civilizations start flourishing by the engineers. Okay? Greek and Roman engineering. So the era from, say, 5,000 years back BC to 2000 BC, so there were a lot of things happened, and they started building the civilizations. Then, the Alexander started moving here and there, so he started bringing a lot of engineers and wanted to make warfare, and technology slowly got diversified. Even in India, we had a lot of technology. Even there is one pillar in New Delhi. In fact, I have seen that. So far, we don't know what is the chemistry and metallurgy of that pillar. Still, there are a lot of PhDs done on it. But this pillar is also one of the old and ancient structure. It is not tall, but one of the very ancient material science marvels, the pillar in New Delhi. I think it's near to Qutub Minar, I guess. And so we call that period the engineering science in East. So in the Middle East and also in China, India, there are a lot of research, R&D done on mathematics, engineering done using mathematics, right? And there are many products, many technologies have developed. We call that period as engineering science in the East. Can you please mute co-host? So the third development, engineering development, as per the records, was happened again in Europe, because there were many wars. I think someone said what happened, they were fighting, so there was no development. But there was development. There were many wars happened, Europe, in other areas, even in Asia. And the engineers again started using their knowledge, skills, and experience to build the ammunition, warfare, right? I think everyone has seen the Bahubali, right? In Bahubali 1, 2, you see the warfare, the build. They used a lot of engineering techniques, and the warfare was made to win the wars, right? Some of the developments in astronomy by Copernicus, also Leonardo da Vinci, they have worked to develop engineering and science during the Renaissance period. So engineering is not new to human beings. Even you can see millions of years ago, our ancient humans, they built swords, they built tools to do agriculture, to kill animals, to cook, to do irrigation, to do the construction work. So they were not qualified engineers, but they've used the techniques of engineering. They've used trigonometry, they've used astronomy, they've used optics, they've used light. So the first recorded engineers were, say, Greek and Roman engineers. So they built a lot of ships. Then Eastern science, China, India, Middle East. Then the Renaissance in science, where there a lot of warfare was built. So that's how between the pyramids and the Industrial Revolution, through which the Eiffel Tower was built. Before Eiffel Tower, say in 1800, so starting 1500, so there was a lot of industrialization was happening in Europe. They were building textile machines, they were building steam engines. So a lot of engineering and science was getting developed in Europe, starting from 1500, 15th century, the 16th century. So we call that period West Industrial Revolution. So starting from 16th century. And when we come back to our ancient Indian history, and in fact our religious scriptures like Mahabharata and Ramayana, there are so many constructions you can see there. Even there were flying machines, right? And there were a lot of warfare, like Garuda, and also there are many aviation technologies. But it was not recorded or existing right now like pyramids, but there were a lot of scripture says there were aviation, there was a warfare development, even there were a lot of civilizations like in Mohenjo-daro, Harappa. There were a lot of civilizations were developed by engineers and the common public. Now we are focusing a little bit on West Industrial Revolution. So James Watt, right, started developing a steam engine, which started again the big revolution in West. And everything started becoming a product. So there is energy to produce a product. So steam engine used for locomotives, used for running foundries, also used for running locomotives, transportation, many applications have used steam engine and related. So after steam engine, again, electrical technology came into picture with Thomson, Alva Edison, Faraday. So many Tesla, a lot of engineering science started developing in the West. Now, finally, now we are in 21st century, and we are seeing the marvelous structures being built, marvelous aviation products are launched, so we can fly from India to US or anywhere around the world. Now we are going to Mars, right? So the exploration, space exploration, ocean, sea exploration, part of our journey. This is a small brief about engineering history, spanning from Greek, Roman engineering to Eastern science to engineering science developed during the warfare, and a little bit about West Industrial Revolution, where exactly the real engineering started picking up. Now, you can see for the last 200 years, 150 years, there's tremendous development by engineers. Even if you see last 10, 20 years, the networking, IT, communications has been exponentially growing, right? So now the cell phones are getting old in a matter of 3 months. So we started from say 1G, 2G, 3G, 4G, 5G in just few years. So engineers are the front runners, are the backbone of the civilizations, starting from Greek or Roman engineering to the industrial West. So I'm going to stop here. So I'd like to take some questions here before we start discussing about what are the industry variants so far. So what we are talking about today is Industry 4.4 and the employability skills related to Industry 4.4. So before we go into there, so I would like to stop here and ask and allow some questions. Yes. Yeah, please raise your hand. So one of the very important employability skill is responding, giving a response to the material what you have seen. So you should be able to respond, means you should be able to raise a question. Asking question is one of the very, very fundamental quality employability skill for engineers. So if you start sitting in the back bench, so you're not going to be a good engineer at all. So there are 3 skills as far as the personal qualities are important. One is listening skills. So engineers must listen very carefully. Second, they should communicate what they are thinking. So listen, then communicate. So you should have communication skills. Third, then problem solving. one of the very important employability skill for engineer is the problem solving. It means finding out the problem, not the solution. Right? 99% of the time, the engineers, as I said in the last time, work on problems, not the solutions. Right? Not the solution. So let's see the COVID. We don't know the problem so far. That is the reason why we are struggling. We don't know exactly where it was born, right? There are so many ambiguities. We exactly don't know what affecting the human body by the COVID. So there are a lot of confusions, even right? WHO says use remdesivir. Now next day they come and say don't use this. So we are all confused because so far we did not understand. It means we don't know the problem. So understanding the problem, it means you have to listen carefully and you have to ask why. So this is one of the first and foremost employability skill required for engineers. Okay, the moment I say, do you have any questions? I expect 138 students to raise their hand. So I see now only 20 participants just raise their hand. So the moment, it doesn't mean that they're going to ask the right questions. Doesn't matter. Question is question. You can ask any question, but I could give a dumb answer. So answer could be wrong, not the question. Question is question. There is no right, wrong answer, question. It's only answer could be right or wrong. So feel free to ask a question, whether it is your classroom or whether you're listening to any technical discussion or a seminar, ask the question. Okay, let's go first come first. Please go one by one.
Hello, sir.
Yes. So tell your name, tell your college, and quickly the question.
I am Nivas from Vidyaniketan College, Sri Vidyaniketan Engineering College, Tirupati. And my doubt is, as you have said, that there is a gap of 4,600 years between the pyramid and the Eiffel Tower. And what it has been done in that time?
Yeah. So they were building the civilizations. That's what we are talking about. 3 types of civilizations developed. Greek, Romans, 4,000 years ago. Then slowly came back to Europe, Ottoman Empire, I can say Persian civilization, India, Mohenjo-daro, Harappa. So there were a lot of ancient civilizations have flourished through engineers by doing irrigation, building drainage systems, building machinery like Bahubali, what you have seen, building water pumping systems. So there are many systems developed for the betterment of the civilization. So they were not focusing on pyramid, because pyramids are tallest structures were built for the king, not for the people. There is no benefit to the public. So engineers were free. Then they started doing what they love. So this is what we are talking about. Industry 4.4 and the future, the goal setting. So we are talking about engineers setting the goals. What for? It's not for you. The goal setting is not for you, for the community, for the country, for the public, for the society. So you can become, say, a rich. If you want to become rich, no, engineering is the wrong profession, right? So engineering, like medicine, they are professional courses. It is for the society, not for yourself. Yes. Next question. Hope the question is answered. Yes.
Thank you, sir.
Sir, my question is about industrialization, sir. Sir, as the industry is automated during these years, how we will be facing employment problems now, sir? How to overcome that, sir?
Oh, okay. So the automation started in Industry 1.0. Similar questions were asked during Industry 1.0, Industry 2.0, Industry 3. Industry 4. Even in Industry 5.0. So these similar questions will be asked, but nowhere it is seen that employment got affected. But unfortunately, every time there is automation or there is some industrial revolution, there are many products. There are a lot of improvement have been done. Okay, can you please mute? So there have been benefits of industrial automation. So it's never been a matter of concern. Okay, never been. Hello. Hope the question is answered. Yes. Next.
Sir, my question is about how can you classify that industry 1.0 and 2.0 and 3 like that?
Yeah, that is the next lecture. Kindly bear with me.
Technology.
Kindly bear with me. So we are going to explore. Yeah, that is the next lecture.
Technology.
Okay. Any other related question on history of engineering, or we can go ahead? Now it's almost like 1 hour. Okay, so let me stop here. And give me a minute. So I have a couple of PowerPoints open. So, okay. Do you see the slide called role of engineers in the society?
Yes, sir.
Yes, sir.
Great. Okay, so there is a very big role of engineers in the 21st century. So I did not explain. The slide is very self-explanatory. So the moment you get up, right? The moment you get up using a cell phone, alarm, or any clock, and start using your brush, right? Taking a shower, whether if you want to cook food, you want to travel, right? So all the aspects of your 24/7 is administered by engineers. So there is no a single product which is not developed by engineers and which is not used by the common man. So wherever you go, whatever you use, so you are using a product or a system or a process developed by engineers. Even you go to a doctor, the doctor takes the stethoscope and test, developed by engineers. You go for MRI, developed by engineers. There is a syringe, you're taking a shot, developed by engineers. There is a drug, right? Manufactured by chemical engineers. So every aspect of the human civilization in 21st century is having a connection with engineering. Okay? So we should really appreciate and acknowledge the so far the greatest engineers even India given to us, starting from Sir Visvesvaraya to Sir Dr. Abdul Kalam, right? So there were many great engineers served by the nation, and they have done wonderful job. And why we are here today is because of them. Can you please mute co-host? Hello, co-host. Can you please mute?
Rashid, mute చేసుకోమా.
Okay, thank you. So do you have any doubts on this? Any doubts on this? No, right? So we should be proud, and you should be proud that you are studying engineering. So you're part of.
Sir, shall I ask question, sir?
Okay. You have a question?
Yes, sir. It's
Yeah, go ahead.
Sir Abdul Kalam was said in the year of 2020, our India become was one developed country, sir. But now itself only India was developing country, sir. Not yet developed, why, sir?
See, this is again, let's not talk politics. So because of the pandemic, everybody is confused. There is a lot of stress in the system. That's why now the Huner, like yeah, my apologies. I think it got disconnected. Can you hear me? Am I audible? Hello?
Yes.
Great.
Yes, sir.
Okay. So we are talking today. Wow, engineers are great, right? Engineers, they have done so much, starting from getting up to sleeping. So we have done wonderful jobs, right? And great, right? So we are doing we are raising our collar. But unfortunately, we were also responsible for harm done to the society. So this is very important for engineers to understand how we can harm the society, not just help the society. So there are three types of problems we can create to the society, especially by engineers. So when doctor is going for a surgery, when he's doing surgery, he could kill only one patient. But a genetic engineer, he can modify a certain drug or certain, like what we are talking about, some problem with COVID. So he could do, he could devast the whole civilization. So we are most dangerous than doctors and any other professions. We are the most dangerous professionals. And even there were many failures to launch rockets, right? There were many problems, many failures, construction failures, right? You have seen many accidents. Even though they are accidents, they're unexpected and unintentional. It means as engineers, we could harm the society unintentionally and with unexpected results. You built a bridge, and imagine there's a heavy rains, there was a cyclone, and the water comes with certain turbulence. The bridge could get washed away. Imagine you are lifting something, and the lifting, the wires could have a defect in their material structure and they would have broken. Right? I have to take this call. Sorry. So even though they are unexpected and unintentional, people are going to die. Okay. And let's see. So what do you think? Say, for example, there is a new drug, something like COVID care or something, some drug, which cures say 90% of cancer cases or any severe disease. But there are some side effects of this drug, means about 10% may not be get cured and they might suffer. Okay. What do you think? Shall we launch this? Shall we launch this or no? What do you think? Hello.
Yes, sir,
No,
we can
sir.
launch.
We can launch the 10%. They can die.
No, sir, we are not allowing, sir.
Why? Why?
Because 10% people are going to die now, sir.
So 10% people are going to die. So we should not allow this drug to be manufactured or launched, right? Hello. How many of you agree? So let me take a poll. Okay.
Yes, sir.
So let me take a poll. Maybe you can just in the chat. Okay. No, better than chat. The poll is better. So let me take a. I think okay, it will consume time. So just leave it at this time, the poll, and you can speak whether shall we launch this or no. Hello.
No, sir.
No. Okay. Is someone
No.
here to say yes or no?
No, sir.
No. What?
Sir, if the condition was critical, we will launch the drug, sir. And we will cure this all effect later.
Can you tell me, is there any medicine which is not having any side effects?
No, sir. Every medicine will
No,
have a
sir.
side effect.
Everyone will have, sir.
No, sir.
Sir, if we launch today, then future generations will have the medicine, sir.
Okay, so there is a ambiguity here, right?
Ayurveda medicines have no side effects, sir.
Okay, so there is some
Like which
ambiguity.
will
So
evaluate that.
let us see. If you don't get an answer, let's leave that. Let's take some other product. Okay. So there is a product. The side effects will kill 50,000 in North America alone. So in the whole world, the product could kill many people. So should it be launched or developed? Should it be developed or no?
No, sir.
No?
No, sir.
No, sir.
No, sir.
So you are not going to ask what is the product?
Yes, sir.
Yes, sir.
So in the previous example, we thought it is a drug for the cancer, right? So you're not going to ask what is this product. You want to see the product before you take a decision.
Yeah,
Hello?
we will check it, sir.
Okay. Hello.
Yes, it should be developed.
So this is called expected harm. When we are designing a product, something like automotive, we know there are certain design constraints. And if the design brakes fail, it's going to be an accident, and some people might get harmed or might die. So any engineering product, a design has its limitations, has its factor of safety. So when we design, we use the factor of safety and we launch the product. If something happens more than the safety limit, so it's going to have an accident or some problem. We call this kind of harm the engineers are going to do to the society is unintentional. We don't want people to die when they drive a car, but there is an expected error in the design and the manufacturing and expected outcome. So what are the expected outcomes? Failures of this car. Brake might fail, right? Tires may get burst. So it may start to roll over. And when you apply brake, so you may hit the dashboard. So there are expected issues, problems. Engineers were going to have certain safety parameters built into the design. So something like airbags, seat belts, right? Anti-friction, right? Brake systems, like we say ABS. And the tires are tubeless tires now. And the body, the chassis can withstand even the rollover, or it can, the bumper, the suspension can withstand certain impact load. So we're all design considerations we put into the product in the system to take care of certain issues. So this is the limitation. So engineering is not 100%. So engineering is approximation. So we do calculations using science and we say, okay, instead of 1, the factor of safety is 5. So it can take the load up to 5 times what it is designed. So we have certain factor of safety put into design and we build these products. But yet, the product could fail. So engineering so far has limitations and it's approximation. So it's not 100%. That's why you see many failures in engineering construction, engineering product, engineering designs. So there are errors, the calculation errors, the data entry errors. So we discussed 2 types of harm. One, unexpected, unintentional. Second, expected but unintentional. We don't want people to die when they are driving the car, but there could be a harm while driving. Okay, we said this could happen. And the third is the most important harm by engineers is expected and unintentional. Okay, expected and unintentional. Something like a Bhopal gas plant disaster, like a Chernobyl, like, right? So these are expected, right? Something may happen, but unintentional. There are many things happen. So this is where the problem comes into picture. If you feel as an engineer that this could go wrong, and if you do not take care, so that is your prime responsibility. So in the Bhopal gas, I don't know how many of you know, so there was an issue of tank leak. So leakage is a technical error, maybe the product malfunction. Because that was isocyanate, the most dangerous liquid, the most dangerous liquid. So when someone stores that kind of liquid, we know if something happens to the tank, it's going to explode and many people are going to die. So how do we take care? So how we should take care of these kind of accidents, expected accidents? So many times we fail. Some of the engineers fail to make it safe, the expected harm. So this is one of the very, very challenging and most pathetic harm by engineers. So if you become in future, you know there is something going to happen. So this is your moral responsibility that you take care of that expected accident by stopping it or improving in its design or safety requirements. And the last, expected and intentional. So you know there's something going to happen, unintentional. Say, we don't know, there are many rumors that this COVID is generated somewhere. And if it is generated and if it is done by an engineer, he knows something is going to happen. If it is intentional, imagine, that's one of the suicidal. So engineers never attempt this kind of development, even though your government says whatever it says. You should never attempt this kind of expected and intentional harm. You should never. It doesn't mean that you are not developing a missile, or you're not going to say stop developing a nuclear reactor. No. So we are talking about something intentional harm, intentional. So we should never go near or here to this kind of harm. So we have a great role in the society for the betterment of human condition. And we as engineers are the most dangerous and responsible professionals in the society. Okay. Now coming back to the, again, $1 million question. So Hiroshima, Nagasaki, what do you think? Is it really, can you justify that this kind of warfare to be developed? So I have 10 more minutes. Hello.
Yes, sir.
So
No, sir, that kind of engineering is not good. The type of engineering is good, sir, but not for those things to destroy something.
Any
It should be
other?
needed, sir, but it should be needed, but for the sake of defending only, not using.
Okay. Some more. I don't
Why
see
should it need?
the voices of girls, please. My daughter is a mechatronics engineer, graduated from Simon Fraser University, Canada. So I encourage women engineers a lot. So please speak up. Okay. So coming back to this intentional expected, so these are political, right? So we don't have any control so far. But before the expected, unintentional, so there were 3 types: expect, unexpected, unintentional. So engineers could avoid those situations. Engineers could avoid those situations. But whereas here, so these are political. So engineers do not have any control over this, unfortunately. So once Einstein said, okay, if I had only known, I would have been a plumber after Hiroshima, Nagasaki. Right? That was his remark, his comment. If I had only known that this E is equal to mc square is going to create so much havoc, he would have not become an engineer, he would have become a plumber. So what makes a professional engineer? To be an engineer who is going to work for the society, for the betterment of the human condition. Self-learning. Once you get your degree, the next 30 years of your career, it's only self-learning. So if you have studied 4 years, you're closing your books. No, you're in a wrong profession. Like doctors, even engineers have to update every year. There's going to be a lot of professional development. So you have to keep up to date. You have to keep up to date. Whether you're a computer science engineer or a mechanical engineer, whether you're a chemical engineer, you have to have this self-learning. Otherwise, you can't become a professional engineer. Second, so you should have a critical and creative thinking. Critical thinking means you should question why, how, what, when, why. So you should have a critical thinking. So should not take anything as granted. So the very popular example is Samsung. I think some few years back, Samsung batteries were exploding, right? So those engineers, they took it as granted when they changed the operating system. They did not upgrade their battery. So operating system was generating so much milliamps and heat, and they started exploding. So they took that as right, granted. They took it as granted. So this is called the critical thinking. So you need to be critical, not just creative. Okay, when you are creative, so there are going to be many problems in the product. So you have to be critical before it's released to the market. And utmost, ethics, engineering ethics. Let me tell you, in North America, even you have a PhD, you are not called engineers. So engineer is a trademark registered by the Association of Professional Engineers. So you have to earn the license to practice in North America. So you have to have all these 4, and roughly approximately it takes 5 to 10 years to become a license, to get a license. So I studied in North America. So it took me almost 10 years to get a license to practice and tell me I am a professional engineer. So if you see my CV, Abdulvali Syed, the PEng, professional engineer. So you get a stamp and you get the authority to release the drawings, to certify. Why? Because as we were discussing, so engineering is the most dangerous profession in the world. So it has to be self-regulated. How can you do self-regulation? Unless until you follow your ethics. So there was a law and ethics exam you have to pass, and you have to take an oath in Canada, for example, to me becoming a licensed engineer, you have to take an oath on law and ethics, and you have to pass this exam, professional law and ethics. Then I was called as a professional engineer, and I was having 1 million insurance. Why? Because as engineers, we are going to make errors. So engineering is approximation. We are going to make errors. It means mistakes. Mistakes are common. So someone can sue if I approve certain drawing, some design. So I used to do my own consulting for fire systems. So I used to certify the fire system. I was only one of the 2 engineers approved in British Columbia, the state called British Columbia in Canada. So I was one of the 2 engineers approved for licensing as giving permits to the spray booths, paint booths. You take any car, it has to be spray painted, and it has to be done under specific conditions. Unlike we see in India, everybody can take a paint can and do. Unfortunately, that's illegal in Canada because the paint has isocyanate. what was there in Bhopal gas tragedy. The paint has isocyanate. And if you are continuously get exposed to the isocyanate, in few years, you will get cancerous. So you will get cancer. So the paint booths have to be regulated and built with the safety so that the painters won't get affected by cancer. So that was one of the profession I was doing. So to a short, so ethics are very important for engineers. So if you do not follow ethics, even though you are a great engineer, so you are going to generate some disasters. Okay, disasters. So what makes a professional engineer? Self-learning, creative thinking, critical thinking, and ethics. And over, you have to build your employability skills in personal attributes, problem-solving skills, and technical knowledge. So I'm going to end this. Now we are going to have the next session on Thursday about goal setting. So what kind of engineer you want to be? So this workshop, internal digital internship, starts questioning yourself, what kind of engineer you want to be? So this is the most difficult question to be answered if you are in a college. And you see many engineers are out without a job. They're struggling because they did not ask this question when they were in college. You're lucky. Now someone is asking you that what kind of engineer you want to be. So this is going to decide your career. And what kind of employability skills you must earn, you must acquire to reach your dream, reach the goal of becoming the kind of engineer you want to be. So it's not easy. So there are 3 questions we need to ask. What kind of engineers you have to be? So briefly, I will touch, but we'll have a very detailed presentation on Thursday. But so I'm going to give you some homework until then, and you should be working on it. Okay. So let me just give me any questions. Meantime, I have 2 minutes, so we can. Hello.
Sir, we need registration form, sir.
It's already circulated. Hello. I can circulate after this. It was circulated, I think, more than 3-4 times. So I will circulate the last time. Okay. And without registration, so you're not going to get the certificate or the attendance in the coming. Okay, now we have a homework for you. I will be circulating the daily task tomorrow. So your goal is what kind of engineer you want to be. So you have to do in 3 steps. The first step is you need to list 2 options of the industry you want to work for. Okay. Industry, whether you want to work in automotive, or you want to work in aerospace, or you want to work in medical field, where do you want to work? Second, so you need to shortlist 2 companies. Okay, after you select, say for example, automotive. So you are interested in automotive and you want to work for Kia, or someone wants to work for GM in India. So let's only think about Indian subcontinent. So if you're selected, say, automotive, then Kia, then third, where you want to work in Kia? Where you want to work on shop floor, a manufacturing engineer, or you want to work in design, or you want to work in marketing and sales or product development. So where do you want to work? So the next webinar on Thursday is going to be on this goal setting. So what kind of goal you have to set and how can you set? Unless until you know what is your interest, right? Now I'm stopping here. I'm going to ask, does anyone know what you want to do? Hello? Yeah, go ahead. Harshita, tell me what you want to do. You have a vision, you have a goal so far. You know where you want to work, which company, what kind of role you want to be. You want to be in manufacturing or design, or you want to be in supply chain, or you want where exactly you want to be. Don't tell me computer science, mechanical, they're all disciplines. Once you graduate, you would be working for any company anywhere in the organization. So organization won't work based on the branch. Okay, there are chemical engineers working for Google, right? Okay, Sundar Pichai. You know what kind of engineer is Sundar Pichai? Any guess? Hello?
Metallurgical.
Mechanical engineering.
Chemical and metallurgical. Okay. So there is no relation between the branch you study now, what you're going to do. Okay, so the bottom line is these 4 years. So you're improving 3 employability skills: personal qualities, second, problem solving skills, and third, your technical knowledge. So technical knowledge is only 20%. Remaining 40 is your personal and problem solving skills. So given a situation, any engineer should solve any problem. That is a skill. That's why people run for engineers. Something happens because problem solving skills are the very important skill for a human being, for the survival. So to acquire problem solving skills, it means first of all you should find what is the problem. How can you find a problem? First you need to understand the domain. For that you need technical knowledge. But just technical without having the techniques, problem solving skills and personality, you're not going to find a solution. Never. Okay. So your homework, I'm going to send you one Excel file where you can start looking into it. So research industry, shortlist 2 companies where you want to work. Then opt, whether you want to be in design, manufacturing, or any other, the field, we call field. Okay. And get ready for the next webinar. So next 2 days, you will be working on this 3 bubbles and setting your looking what goals available for you. Okay, I'm going to stop here. Now it's exactly I think 8:30. Yes.
Sir,
Yes.
I am Ravindra, sir.
Tell me, Ravindra, where are you from?
Sir, I want to invent something and discover something, sir. I doesn't know that something.
Yeah,
And
just complete.
when I am going to set my goal, and there are many fields, sir, and I will search about a thing, and I will try to do it, and I will fall into another thing, sir. I doesn't know why I fall like that. And when I am going to design a computer, my mind directly goes into processor designing. And when I think about processors, my mind directly go about what is sand, silicon. Processors are invented by silicon. Then silicon was that processor was developed to maintain systems like that. I will go to a long hierarchy, sir. I doesn't know what I'm doing and nothing, sir. I
it-
will get
okay,
into
it's-
dilemma, sir. And
it is called,
it is hard to fix my goal.
Okay, so it is very
That-
general, common for engineers, because engineers are creative. Okay, they want to do something for the country. You're always looking for creatively. So this is one of the syndrome of engineers. It's called invention syndrome. So that is reason now we have these sessions. So now keep aside all the stuff. Now what you have to do, you select any, right? 2 industries where we want. Now don't start jumping here and there. Select 2, then select whether you want to work in design and manufacturing. Then be ready on Thursday. We will discuss in what to do. Okay. So this is what you have to do. So most of the people like you or like me is not new. So the challenge is you don't know what you want. Right? So that is the problem with engineers. So during this 4 weeks time, let us see how can we narrow the gap, okay, between your goal and what you want to do. Okay.
Okay, sir.
Yes.
So
So
what
see,
if my goal was wrong?
don't worry.
When I decide in this.
Don't worry. You will get the answers in the next. Okay. So first do this.
Okay, sir.
Okay.
Okay.
Any? Yeah.
Okay,
So yeah. So thank you, and see you on Thursday. So I will be sending you the information.
Thank you,
about
sir. Good night,
goal
sir.
setting. Good night, and please follow my WhatsApp information. Okay.
Okay, sir. Okay, sir. Compulsory, sir.
Okay, sir.
Can it
Okay, sir.
available on YouTube, sir?
Yeah, it will be on YouTube. Yeah.
Okay, thank you.
Sir,
Sir,
good
please
night, sir.
take
Sweet dreams,
registration
sir.
form, sir.